This is a Benji project here. This is the receptacles and lighting for one wedge. This was, what's below us? Living room is below us. And here's some more wiring, also goes to the living room. Breaker feeds in from the top. And this is for the white wire if we ever do 110. The white wires will go on this ground lug here. These metal bars are bolted to the concrete, which isolates them from everything electrical. And the big bundle of red wires are 3- and 4-way switches run all the way around the house. Okay, I paused a piece of video here. We're just looking at a walk around video from a while back, July 17, 2020. Stuff comes back to haunt you. This is how we handled the wiring of the house. We used whatever we could buy, and this is a way to we can connect wires from one thing to another through a terminal block. These are big and bulky, but they do take 2 wires apiece. The orange terminal block over here, we put 2 of those in every box. And there's like 21 wires that go from one sub-panel enclosure to another, all the way around the house. They're fed off of one end by either one breaker for all the lights in the house, or you can have them in zones. Whatever you connect that lead wire to, any switched 3- and 4-way switch wire turns a track on. Anything you wire into that track comes on with the 3- and 4-way switches. We have 6 tracks. Most of them have 10 light fixtures apiece and are like in a ring. Like around the fan in the spider beam, there's one set in the center. Those canister lights like Filipino uses, Texas Filipino. And around the outside are spotlights from All Home. There's some pretty nice fixtures. I mean, we really like them. We're lucky enough we bought 20 some of them. I had to order some in and then go pick them up. The problem with this is getting a second wire into one side. We can go one wire in, one wire out, but when you go to connect your light that might be coming into this box from one of those rings and have to connect to, say, ring 1, you got to put 2 wires under that. And of course, some of them, there's another orange block over here, and any wedge that's got 3- and 4-way switches, like on the next level down or around by the helical stairs, at the top of helical stairs, you go down to the switches and you come back up and you land them on a second orange block, and from that, you dive back into a piece of concrete and go around to the next sub panel. There's 10 of these sub panels on this level. There's not really rooms, though. You could put a bed in 4 of them, I think. You could make 4 bedrooms up there and 4 modest walk-in closets, or maybe just stepping. They're not very deep. They're only 3.5, 4 feet deep. This terminal block, while it works, and it's for what it is well made, it's just not. It's not as easy to work with as what we like. So we're going to replace these. I've already got them here at the house, and we'll do that, a video on that, and I'll show you the difference in them. And we're going to put a piece of DIN rail down with like 10 terminal blocks. They look like Dinkel blocks, but they're very well made, extremely well made. And they were 3.5 cents a piece from China. The equivalent block on eBay was $1.46 each, so 3 cents to $1.46. I'm kind of convinced that Alibaba's got a place in my future. I bought a lot of electrical stuff there. The stuff for the solar powerhouse. I wanted to break some 400 amp, 48 volt DC circuits with 1,000-volt insulation on the thing and flashover protection. They listed for $10, but I got some a much bigger model and stuff, and they were I think they're $49, something like that. And then I got some PV disconnects that disconnect 2 strings, and they were like $19. All 4-pole. Those are 1,600 volt resistance between the different wires, and running 2 different strings through them, you can only go to 600 volts. And that sounds like a lot, except that you got to realize that those PV strings are 336 volts. Only 13.3 amps, but they're 336 volts. So that's some overhead to 600 volts, but not all it sounds like it ought to be. Let's run this video ahead a little bit. Metal bars are bolted to concrete. This isolates them from everything electrical. And big bundle of red wires are 3- and 4-way switches run all the way around the house. I thought we were going to look at the top up there. Okay. And we are looking at the top up there. This is our heavier wire coming in. Looks to be number 8. Could be a 6. We use 6 and 8 depending on what room it was. You'll notice how this wire is not really under that screw very well. From what you see here, this crease in the panel that's behind that wire to there. That's the side distance you got to deal with to try to bend a wire this thick and get it under the screw up in there that you can't see. This is coming in on this breaker. We're using it for a main fed backwards, and that's traditional in the Philippines. But we do have a main breaker down in the power room downstairs that shuts off this box. And also our 110 that's coming from down there, it comes up the same pipe. It'll have a bond wire and a white wire to additional terminal strips, which are not in these boxes currently. We're taking the orange blocks out to put bigger blocks in so we can wire them easier. It's not that they haven't got enough insulation or that the wire don't fit under the screw. It's just working down in a box. We need more space to feel comfortable with what we're doing. So that's what we're going to do. This was probably a note from me. I'm real good at printing stuff out down at the Xerox store and handing it to them. Most of them can cipher through and read English. They just don't want to. Either they haven't ever tried to speak it, or they haven't spoken enough to feel confident enough that they can't pronounce the words right, so they don't use it. If you try to speak Tagalog to them, you can't complete a sentence. They stop you 4 times and correct your pronunciation of every damn word till you have no idea what you were going to say. Frustrating. Anyway, this is the typical space you got in a Philippine box to put the breakers in the wire. I haven't been able to find one that's got more space. Now, we will eventually get these wires under this breaker by folding it back, unsnapping it, pulling it up out of the box, get the wires seated in there really good, put a torque wrench on them and tighten them just to the right torque, and then we'll snap them back in there and bend these as we go. So we can get that in there. All these other breakers, on this first iteration, we had like 3 wires hooked to most every breaker, every screw in every breaker. I couldn't tell you how many of them you could pull out just by grabbing hold of them. You couldn't tell. You couldn't see what you're doing. So we're gonna put a row of terminal blocks on another one of those steel straps like you see on this video here. Let's see. Here we go. This is a flat piece of bolted concrete with a 5/16 bolt into a lead anchor. Bends up to the height you see here. It's about 1.5 inches offset. That's so we can run a bunch of wires behind it rather than over top of it. And then it's got a strap that comes up another end like that. But there's room for 2 of these blocks with about a 3-inch space between them on every one of them. You really can't see the menagerie of wire that's in this box. This is a Benji product. You can tell he's fairly neat. He worked with the hired-in electricians that pulled the wire into the main panels. I couldn't call for inspection because the wire they used was way too small. For the center neutral for the 110, they drove an iron rod in the ground and connected it to that. There's a whole list of things that's common practice over here that I'm just not going to have. Not doing it. The center tap is on the transformer. I was toying with the idea of just digging a trench from our meter base where we ran our wire to be hooked to it, to that center tap, but they tell me there's none up there when I go to the engineer's office. But I've sat there and looked at it and took pictures of it, but they don't believe me that that's my transformer or whatever they don't believe. Anyway, they're not going to hook to it because I'm not in the Clark area of Manila. See, if that transformer went out and they had to put one in, they may not have one with a center tap. So they're going to put a transformer up and just leave my wire hanging there. I could go for that, at least I'd have it for a while. In any event, digging the trench and just hooking it to their ground rod, which is what they connected that center tap to, that would work. But I don't want to do that in a country I'm a guest in. Well, not just that they might deport me, or they might be charging me with some kind of a crime. I don't know, probably is a crime. I'm just not going to do that. I don't think it's the right thing to do. So we bought toroidal transformers. That's a ring transformer. It's not a rectangular thing with 2 coils on it, like side by side, with the magnetic fields interacting. This is one coil wrapped on top of another and it goes around in a complete circle. There's no center taps on it. It's a fixed, half the voltage going in is the voltage going out. So if I put 240 in, I get 120 out. If I put 280 in, and it's adjustable with the solar system. I can ramp that voltage to anything I want, up or down. It conditions the power. You can have a real clean sine wave and on phase, not a power factor correction of almost 1, and it doesn't have voltage that goes from 240 down to like 167 and then 90 and then up to 300. I'm amazed the wiring survives it. Oh, these boxes, by the way. Boy made me some boxes. That's Lucas Dalanon. He's the younger ones. All the younger ones are Dalanons and the old ones are Yatigas, like Boyette and Biani. Alicio, they call him Nane. Their daddy died and their mother remarried, and so the rest of them have the other name. Anyway, he built me these boxes, and you can tell that they sealed out the concrete pretty clean. And these were just set into forms when we poured this. This is a post for the house. This holds up the spider beam. So this is like 24 by 28, something like that. Got a bunch of rebar in it. Got a zillion pieces of conduit. Like you see here, 2, 4, 6, 8, 9. I couldn't tell you there's one in. I would assume there's one back there, but the worst, there's 8. You got a couple coming in from the back here, usually 2. And then coming down from the top, it'll be above the circuit breaker, which is sitting above this this wiring box. There'll be 4 more going up to the spider beam and out across doing things upstairs, at the top of the house. And you see there's a white wire and a green wire, and here's a white wire, and somewhere in that bundle's a green wire. And then you have the 220, and then you have hot leads for 110 times 2. That's so we can have a 110 and 2 receptacles back to back in a wall. Never mind that. That doesn't make any difference. Anyway, Benji's pretty neat. And if I'd have gave him the right size of terminal blocks to start with, we'd be done with this project. The only thing we have to do before we turn it on we have to put the wires on the receptacles downstairs. I think they're just in the boxes. I don't think we ever put the receptacles out. We got brown receptacles for 110 and white and ivory for 240. And then we'll put labels on them. And I don't know how else we keep people from plugging stuff in. But if it's being run as a bed and breakfast by future generations, that's up to them how they tell their customers not to plug their hair dryer and whatever little charger adapter into the wrong voltage, because it's going to turn to smoke. Won't hurt the house. It's poured concrete. and the wiring is all sized for the minimum 15 amp breaker that we can buy. Now, I now have got breakers. I can take them down to 1.3 amps if I want to. If I wanted to put like 6 LED light fixtures like what Tex Filipino uses, and the total draw is like 4 amps, I could put a 5 or 6 amps breaker in these, they're fuse holders actually, not breakers. Could have got breakers, same place. I got fuse holders. If there's something wrong and it kicks it out, I want to be the one who has to put it back working. I want to know why it went out, not just turn the switch back on and see how long it stays. Because somebody's going to be turning that breaker back on right when it's in transition temperature, and then the breaker won't never work again. It's like motor starters. If you reset a motor starter in the industry, they work by melting solder. It gets the solder so hot it melts, and then a shaft slips in a hole. It's got a gear on the end. So when the gear turns, it lets a little arm out and drops the power out. And that shuts all 3 legs off. But if somebody goes over there and pushes that button in right when the solder's freezing, they disrupt that solder joint, and it's not connected anymore. And that makes the old man have to take that thing off the wall and take those pieces out and heat them up. You can take the breakers off, or the heater elements off, with it on the wall. But if you have problem with the escapement behind it, the only way to put it together is take it off. You take the back off, you put all the parts in there in a heap, you drop a piece of string around the shaft of it, pull it through a hole in the front and hold it, and then you set the back on and screw it down. If you don't know that trick, you buy a new damn breaker every time somebody does that trick. So I got a whole bunch of free breakers, and I put them right back together. Anyway, this is one of my masons, and he's also does the he's part of Benji Boy Construction that does the window grills. He's half of that. So he does things neat. Okay, that's enough of sub panels, which is what this video is about. I think we need to go on to toroidal transformers. So I'm going to stop this, and then we're going to start on one for that.